So part 5 out of 11 of our relations and functions is about solving problems that involve quadratic equations. This is going to be very similar to the word problems that we saw in Math 20-2. They're going to be word problems where you have to figure out how to represent them in quadratic equations. So we may be dealing with the farmer who wants to build a pen with the maximum possible area given a perimeter P of fencing and that there is some sort of wall that he's going to pen his livestock up against. We often have the border problems where we have a rectangle, there's maybe a pathway around something or a garden in the middle or a swimming pool. These are all common setups, but the idea is to figure out what the area of this strip is going to be, or given the area, figure out its width. And it's usually a uniform width, so that the extra x bit there is the same as the extra x that we add on here. That will make it a quadratic equation. We frequently have price optimization problems, where every price increase will increase the profit per sale, but decrease the number of sales. So then if you graph your revenue based on the price, you're going to get a quadratic. And we're going to be often dealing with the peak revenue that we have here. Sometimes the peak profitability when you subtract the expenses away from it, where the expenses are often a straight line. So these are the most common problem types. The last one that we frequently see is one that borrows an equation from physics, where the height of something that's jumping up through the air is given by the equation, if we make d as a function of t. So the distance traveled is going to be your initial distance plus the initial velocity times the time elapsed plus 1/2 the acceleration times time squared. So when we talk about something that's jumping up in the air, we often see a negative 4.9, sometimes rounded to a negative 5 here when we're working in meters per second squared, because the acceleration due to gravity is negative 9.81 meters per second squared. At least that's what it rounds to in most of the world. It does vary a little bit according to your latitude and your altitude, because the Earth's rotation makes it bulge in the middle, so the average distance from the center is greater at the equator than it is at the poles. So the poles have slightly higher gravity than we do at the equator. But again, these are just the most common sources of question types.